Okay, guys, so today's going to be a pretty easy day except for the word problems we do, which get a little tricky, but this is pretty much a review of some things we've been talking about already. So we're going to be talking about finding sinusoids. All that means is finding a sine or cosine curve that will fit data. The only thing new with this is they might ask you for the frequency. The frequency is going to be 1 divided by whatever the period is of the function. So therefore, the frequency of a periodic function is just going to be the reciprocal of the period, since it's 1 divided by the period. So just a real quick problem, making sure we understand the frequency. So first on this, we'd want to find the period. Do you guys remember how to find the period of sine and cosine? Right, it's 2 pi divided by b. What's our b value here? 4 is the b value. B is just the coefficient of x. So the period is going to be this, and that's pi over 2. And so what is the frequency going to be then? 2 over pi, just the reciprocal. All right, let's review the 5 key points for sine. I know we've done this over and over, but yesterday we did cotangent, so just making sure everybody remembers these for sine. How does it go for sine when we use those quadrantals? Good. And then we've got our cosine curves. Let's use the same quadrantal angles. And key points go what? Good. All right, so on sine, we know this first, third, and fifth value will always be the same. If they are something other than 0, what does it tell us we have? A shift what? Up or down, good. For cosine, our values that are the same that are on that axis are going to be here at pi over 2 and 3 pi over 2. And if those are different, that's also going to be a shift up or down. So this first problem should be pretty straightforward for you. We've got a point here at 0, 3, pi negative 3. I want to know what the curve would be. The sinusoid is another name for that. That would go through those points. So no longer are we going to be given 5 points. Just by looking at this, the hope is that you can come up with the function. So we know, look at the point we have. We're given 0, 3, pi negative 3. So what's this point here? 2 pi 3. Okay, what do we have in the middle here of these? Values of what? Right. Right. Okay, so now just think about it. Looking at that graph, you should know what the curve is. Look at the pattern. Here, let me do sine up here again. Just looking at the pattern, it goes 0, 1, 0, negative 1, 0. There's how sine goes. For cosine, it goes 1, 0, negative 1, 0, 1. That's for cosine. So what does this look like when I look at it starting here and ending there? Cosine, good. Now we know for cosine, it's going to go A cosine B x plus or minus C, and then plus or minus D. Okay, A is affected by the amplitude. Is there a change in the amplitude from normal? The amplitude is normally 1. Is it still 1? What is it now? It's 3, actually. So it's going to be y equals 3 cosine. Is there a change in the period? The period is how long it takes for it to start repeating the pattern. Is there a change in that period? No. So therefore, B is just going to be 1. Is there a shift left or right? No. And is there a shift up or down? No. So what is it going to be? Just y equals 3 cosine x. Good. Now, in the directions, it says there are infinitely many possibilities, but we will find one sine and one cosine function for number 2. After that, we will find a sine or cosine function and not both. So now I'm going to look at this curve and I'm going to try to find a spot on this curve where it reaches the pattern that's happening for sine, where it goes on, up, on, down, on. Here's the picture. When I say on, I'm talking about on the sinusoidal axis or the midline. So here, 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 here. Where would I want this function to start at what x value to make it match up with that kind of pattern? Negative pi over 2, right? Why would I not necessarily want to start here at pi over 2? What's it supposed to do first? Go up. Would it go up if I started here? No. So then that would mean I would have to put what in the front? Negative. So we're going to look at the point starting here. I'm going to go over it a little bit off so you can see it better. So we're looking at that, okay? That would give us just a normal sine curve with no change in the coefficient. So we would know this would be y equals 3 sine, but this was shifted which way? Left. So what am I going to have to replace x with? X plus pi over 2. And was it shifted up or down? No. So the only difference with this is that we're not really going to see the 5 key points like we did with the other ones. With the other ones, I gave you a bunch of points, and it was a little bit easier that way. For this, you've got to be able to look at a picture and figure out what it should be. We will not do sine and cosine for every one of these. We're going to do whichever one does not have a shift left or right, because that's the easier way to do it. So on this next problem, rather than forcing it to be sine, if it's going to go down, on, up, on, down, which one is it going to be when those middle points are in the second and fourth spot? Cosine. So this is going to be a cosine curve. Okay, now let's look at the amplitude. It's supposed to go 1, 0, negative 1, 0, 1, but it's going negative 0.5 and 0.5. So what is the amplitude then? 0.5 is actually the amplitude, but the A value, in order to make it go down first instead of starting up, is going to have to be what? Negative. Now, we're forcing this not to have a shift right or left, so we're just going to keep it as an x, but we have to look at the period. So we're looking at it from here to here. That's one cycle. That's because it's hitting all of those points. It's completing one cycle, and then it continues again and again and again. Okay? So we're trying to find the B value. Do you guys remember the formula for period? 2 pi over B. B is the coefficient of x. So what is this period here from 0 to 2? What's that period going to be? 2. So 2 has to equal 2 pi over B. So what's the B value going to have to be to make this true? Pi. Okay? Makes sense? Now, if I'm not sure on this, and this is on the graphing part or ACTs or something like that, I can always just graph this on my calculator, do a zoom trig, and the window is much different than the way the window looks here. So to make sure that I'm right, I would now go to my window. This window is going from negative 1 to 4 by 1/2, so 0.5. And the height is only going from like negative 0.5 to positive 0.5. And I'm going to have to make this smaller than 1, or it's going to say, what? I can't do that, you know. So I'm going to make this 0.25. All right, so now when I hit graph, it should look identical to this one. And see how it does? Okay, just checking. We could also check the 5 key points by looking at our table and adjusting as needed. All right, guys, let's have you try one now. We're going to actually have you try 2 of them. I want you to try 4 and 5. You can work on your own or with a partner. All right, how about if you just do 5? 4 is a little tricky to see, and I'll do 4 with you. So just do 5, unless you're up for the challenge. Let's get to get out and then I'll just do that. All right, another 15 seconds. All right, raise your hand if you think you know it. You've got a Rice Krispie treat for anybody who is willing to give an answer.
Oh, does it give an answer? Doesn't have to be right?
Well, I'd like it to be right, but. All right, Ryan, you said it first. Go ahead. What?
Or 5?
Number 5, yeah.
Okay, I did 2 cosine and then parentheses pi over 2x plus 1 and then 3.
Let me see if that would work. So you said, now I did say earlier, like to try to do it without a shift left or right, but that's okay. Let's see if it is actually correct though. So say it one more time.
2 cosine and then parentheses pi over 2x plus 1 and then plus 3 is outside.
What's your coefficient in the very front?
2.
That works. All right. That is one correct answer. So once again, here's what he said. He said y equals 2 cosine pi over 2 x plus 1 plus 3. Let's talk about why that would work. If I wanted to make this a cosine curve, it's actually starting here to make it a cosine curve, right? So that's a shift to the left of 1. So if we shift to the left 1, it's going to have to be x plus 1. To find the b value, we can see that the period to go from -1 to 3, that's a distance of 4. So if I need 2 pi over b to be 4, I cross multiply. And I get 2 pi equals 4b, and so therefore b is pi over 2. And then we know that it got shifted up 3 because this new midline is at 3. And so that is going to be our equation, what he's got right there, if we do cosine. Now, did any of you do sine and get this answer? Did anybody do, you got that, Gianna, the exact same one?
I think we did. Oh, yeah.
I just had one number wrong.
What was your one number you had different?
I had 3 wrong.
Okay, and what did you put instead of 3?
It was really stupid. I just put 1.
Okay, here's the way that we know that it has to be 3. It's because the midline is in the middle of our highest and lowest points. So in the middle of 1 and 5, that's going to be 3. We would add them and divide by 2. Okay, I'd really like to hear what other equations you guys had, because I want to point out like what your error was in your thinking if you did a sine curve. What'd you have, Drew?
Oh, I didn't do a sine.
You did cosine? Okay, what'd you put for cosine?
I did 2 cosine pi over 2 x plus 1 in parentheses minus 1.
-1? So
Sorry. Plus 1.
okay, well, once again, this plus 1, that would mean that in the middle of our highest and low points is only 1. So that's why it had to be the 3. And it looks like the rest of it was correct. It was just the plus 1 again.
Okay.
So guys, this number right here has to be in the middle of your high and low points. Okay? All right, let's do this challenging one together. I was going to have you do it on your own, but it's really hard to tell what's going on here. Okay, guys, I really think that you might be better off creating a table on this one. See, I went ahead and even created a table on this one. I think most of us are used to using that table concept. So my first point here is 0, 0. My next point is pi over 6, 2. Guys, what do we know about this table? It has to increase by the same amount every time, right? So my next x value, if I add on pi over 6, what's pi over 6 plus pi over 6? 2 pi over 6, which is what? Pi over 3. So this is 2 pi over 6, and I want to add on another pi over 6. So what's that going to be? Pi over 2. So pi over 2 is actually 3 pi over 6. And now I have to add on another pi over 6. So what's that going to be? Great. Okay, so now let's write these points. The first point is 0, and then my next y value is 2. My next one's 0. At pi over 2, we're at -2, and this must be 2 pi over 3 back to the 0 again. See, this allows us to be able to tell what the period is. So what is now the period going to be? How far to go from here? Just 2 pi over 3. Okay, so the period is always going to be 2 pi over b. Guys, since we're finding the b value, though, do you remember how we're allowed to switch these? So let's use b equals 2 pi over p now. So to find my b value, I'm going to have to do 2 pi divided by, what's this period one more time? 2 pi over 3. How do I divide that? What do I do? Keep, change, flip. So I'm going to keep it, I'm going to change it, and I'm going to flip it. So what is our b value going to be? 3. Okay. So now can we come up with the equation? Y equals, what do you think the coefficient is going to be? 2 cosine, what goes next? What did we say B was? 3. Oh, that's not cosine. I lied. Sine. 2 sine 3x. And there's no shift up or down. That's going to be our equation. Okay? Questions, please ask, because I went through that kind of fast. You feel like you can do that? All right. Let's look at the word problems. These are fun. I love these problems. All right. The pedal of a bicycle wheel is 7 inches long. The lowest point of the pedal is 4 inches above the ground. A cyclist pedals 3 revolutions per second. Write a model for the height in inches of the pedal as a function of time, given that the pedal is at its lowest point when t equals 0. All right, let's work on this. This is awesome. Okay, so here's the, I don't know, what do you call the center of a bicycle wheel? The sprocket center? Okay, center, sounds good. All right, so here's our bicycle wheel, guys. It's got this pedal right here that goes down like this. Kind of looks like a flag, but there's our pedal. And that's going to be 7 inches long, right? That's 7 right there. The lowest point of the pedal is 4 inches above the ground. So it's going to have to be 4 inches above. Can you guys visualize what's going on there? You've got this pedal that's like, here, let me use my pen. You got this pedal like this, and they're going to push the pedal, and it's going to go around, right? Like that. Okay, so we're trying to figure out how high it is off the ground at any given point. Everybody stay with me on this. So at x, let's do t, because they're using time. Sorry, not x, t. At time 0, how high is the bike wheel going to be off the ground? 4, good. Now, it has to make 3 revolutions per second. 3 revolutions per second. Let's do this in seconds, okay? The time in seconds. It's going to make 3 revolutions in a second. So how long then is it going to take for it to make to reach all 5 points? See, here's our first point, here's our second point, third point, fourth point. So 1 rotation or 1 revolution, right? But it's not going to be 1 here because it doesn't do that in 1 second. It actually does that in how much of a second? A third, good. Okay, that's what I was trying to get to, a third. Now, how many points am I going to have to get in here? 3 more points, right? So I'm thinking that this is a distance of 1/3. Let's look back up here. This was a distance of 2/3, right? And we increased by pi over 6. We're trying to space these out evenly. The easiest way to do that is to think of the middle. What's exactly in the middle of 0 and a third? 1/6, very good. This is 1/6. Now let's go in the middle of these two. What's in the middle of 0 and 1/6? 1/12. So how much are we adding on every time? So this is 2/12. Oh my gosh. So we have 2/12. We have to add on 1/12. So that's going to be what? 3/12, which is 1/4. You never knew you would use fractions so much, right?
No.
All right, so now we've got the height of this bicycle wheel. Let's think here, guys. At this point, it's the bottom of this, what's that thing? Pedal, thank you, is 4. What about when it gets to here, when he's pushing or she's pushing back? Then how high up is it going to be? 11. They keep pushing back to here now. There's going to be the end of the pedal. So how high is it going to be now? 18, great. And then they're going to move to here, and how high above the ground? And then to here, how high off the ground? Okay, here is our function. We have our 5 key points. Which are in the middle? Where are our middle points? In the 1, 3, 5 or the 2, 4 spot? 2, 4 spot, right? So it's going to be what? Cosine. So we've got y equals, now let's look at the pattern. It's down, middle, up, middle, down. Is it going to be a positive or a negative cosine on that? Negative. Negative, because regular cosine goes up, middle, down, right? 1, 0, negative 1, 0, 1. So this is going to have to be a negative. Now, how far is that change from this midline to the high or the low? 7. So it's going to be negative 7 cosine. All right, now we have to find this b value. So the b value is going to be the period, or sorry, 2 pi divided by, and what's this period here going to be? So 2 pi divided by 1/3. Can you guys do that in your head? 6 pi, very good. So it's going to be negative 7 cosine of 6 pi. Are we finished? Anybody know what we need? Is it plus 4?
We need an X.
Oh, I do definitely need an X. Thank you. Ooh, get rid of that. Actually, I don't even want to, I'm going to have to fix this, but for now, we've got this. Ignore that. Okay, we've got negative 7, 6 pi x. Is it plus 4 or plus 11? Some people are saying each. It's 11, isn't it? Because it's got to be that middle value. See, this is the lowest point. This is the highest point. So it had to be shifted up 11. Now, if you put this answer, you put all this work into it, you put it into big ideas, wrong. Yes, because they're using t for the x value and h for the height. That's what I was saying when I was saying we now have to rewrite it. There we go. That was a tough one, right?
Yeah.
Do you think you would have the persistence and the patience to do that? I think you would. All right, guys, let's do one more here. The London Eye, the tallest Ferris wheel in Europe, has a diameter of 120 meters, and the whole structure is 135 meters tall. The Ferris wheel completes one revolution in about 30 minutes. Write a model for the height in meters of a passenger capsule as a function of the time in seconds, given that the capsule is at its highest point when t equals 0. Has anybody been to England to see that? Did you guys see it? Did you go on it? Cool. All right. Let's look at this problem then. It's going to look similar. It's going to look similar to our last bicycle example. All right. So we've got this Ferris wheel. Looks like this. All right. So we're starting up here. John was there. We'll say this is John up here at the top to start, right? Okay. Do you guys like having the 5 key points to look at? Okay, let's do that. So we got time and height. All right, so at time 0, how high up would John be at time 0? 135. Yeah. Okay, now it completes one revolution in 30 minutes. So that's where he's going to end up again. After 30 minutes, he's going to be back where he started. Does it really go that slow? That seems really slow.
It's a bit slow. I wouldn't say it's 30 minutes.
Okay. We'll just go with what they're saying. Okay, so we got that. So he's at his highest point here. He's back to his highest points at 30 minutes. Okay, what's going to happen halfway between the beginning and the end? Where's he going to be? He's going to be at the bottom, isn't he? So how high off the ground is he going to be then? 15, yeah, because this total height is 135, and we know the diameter is 120. Yep, so that's 15. Okay, so he's going to be 15 meters off the ground. Okay, do you guys know where to go now? What do I need to find? The middle. So the middle of this is 7.5. What's the middle of those? 22.5? Yeah, 45. Yep, 22.5. Okay, now how high up is he going to be when he hits those like quarter points there? 75 is right. Good. Okay, I'm going to stop. You guys come up with the equation. hear some pin drops. Okay, another 30 seconds, and then we'll go with an answer. Make sure you're using the correct variables. All right, Ryan answered the last one. I want a new person. Who's got it? Charlie, you made eye contact. You're like, I didn't mean to. Anybody got it? I'm looking for eye contact. Drew? Oh.
I already got the last
All
one.
right.
I don't know.
Samuel, what'd you get?
60 cosine of pi over 15.
Pi over 15?
Yeah. Times x.
T? Let's use T. Okay.
Plus 15.
What do you guys think?
I have
Okay, what do you have?
I have 13.5 below the
17.5 below what? No? I don't.
think I did it right.
Yeah, I don't think we would have a 17.5. Cam?
But yeah, I'd say that would make.
Okay. Do you agree with that, Samuel? Replace the 15 with 75? Yeah, because this always has to be the midline, right? So is the middle value 75 in this problem? Yeah. And let's just check this. So the distance from here to here and here to here, that is 60, isn't it? And this is starting up, middle, down, midline, up. Yep, this should be it, right? Were you guys able to get the pi over 15?
Yeah.
Okay, very good. All right, guys, nice job. There's not too many of those on your homework, maybe one or two. Great job.